Experiments in Physics with Dr. Frank Oppenheimer. A brief demonstration of the equipment used in the Library of Experiments in Physics, produced in cooperation with University of Colorado Television. Today's experiment
in this experiment, one can study the discharge of condensers through a resistor. One has a 4 microfarad condenser and a 1.5 volt battery. The voltage across the condenser is measured by this oscilloscope, and inside the oscilloscope there is a resistance to ground of 1 mega ohm, so that's the maximum resistance that one can have across the condenser. The lead from the negative side of the battery goes to the case of the condenser and then to ground. One can decrease the resistance across the condenser by plugging in this banana plug into the top of the condenser, and then this resistor, which is much less than a mega ohm, provides the leak. In addition, one can charge the condenser either by putting this terminal here directly on the battery terminal, or one can put it on the end of a resistor and charge the condenser through the resistor. It only charges when this switch is closed. This is a normally open switch, and as soon as you close it, the condenser starts charging. In order to measure the voltage nicely, we use a storage scope. The time constants are quite long, since this is a 4 microfarad condenser, and one has a mega ohm in here, and we can put that over here. Let's look at that. The spot we usually put along the bottom edge to get the full range. The sensitivity of the vertical amplifier is about 0.2 of a volt per division, and of course one looks at the voltage on DC to measure the actual voltage. When I close this switch, then the condenser charges, and I can leave it charged. When it comes in on the next sweep, I can open the switch and one can see the discharge. The sweep is now at 1 second per division, and you can see what it looks like. But let's try that again with the storage scope. See, it's still discharging. I'll charge it, and it stays at a constant voltage, and as soon as it sweeps again, I'll let it discharge. I can see this exponential decrease and measure the time constant of the decrease and compare it with what I might expect. Then I can charge it through the resistor, and of course then it'll charge with an exponential function shape, rather than charging in such a very short time as it did before. And again, I can measure that time constant and that voltage, and then I can let it discharge and measure the time constant there. You can see it's not quite the same as one would expect. And then, of course, I can do the same thing with a shorter smaller resistance across the condenser. And I get a different peak voltage, and I also get a different time constant. In order to make good measurements on that, you may want to change both the vertical gain and the time sweep. But one can put all the traces on there and then just keep track of which ones they were and measure them after they're all on there on the storage scope. I didn't mention that the sweep is left on auto, and it's internally triggered. I think that's all that's involved in this experiment.